Okay, so in this video, I'm going to be talking about truth tables, and what they do and how they can help you. So, what is a true? Oh, okay. Before I move on, right? I'm just gonna do a little recap on some knowledge that you need to have. So you need to know some basic logic stuff. You kind of need to know about logic gates. But here's a little recap if you don't. Okay, so in electronics, right, there is actually digital electronics where we deal with ones and zeros, right? That's basically it. So you may ask yourself, what is a one? What is a zero? Well, you at this point, right, you should actually know like high voltage and zero voltage. You know what I mean? Like when you have like a circuit, it needs power, so you need voltage. And if it's not power, then there's zero voltage. That's pretty much what ones and zeros are. Ones are usually like 5 volts, and like zeros is 0 volts. So you need to know what logic 1 and logic 0 is. As for logic gates, I'm not going to do a revision. I'm just going to expect that you know some basic logic gates. Okay, so let me talk about truth tables now. Sorry for the hold up. So truth tables, right, is like a spreadsheet that describes the behavior um, of a logic gate or like a few logic gates or some kind of circuit based on its inputs and outputs. So a truth table, basically you will have it you will be able to see like what inputs cause what outputs. Okay, yeah, that's how I would say, yeah. So let me show an example. So let's say we have a logic gate, okay. And let's say this logic gate has two inputs, A and B. And then let's say that this logic gate has one output, which is X. So far that's pretty much it. And then it's a table, right? So you gotta draw your lines that all tables have. So now, right, the next step is for the inputs, right? These are inputs. These nuts. These are inputs. And for the inputs, you're actually going to have to describe every single possible configuration of ones and zeros for the inputs together. Now you may be thinking to yourself, "Oh my God, that's going to be many." Okay, but don't worry, this is not, because it's ones and zeros. So actually, right, you're gonna have four different configurations of the inputs. It's going to be 0 0, 0 1, 1 0, 1 1, and that's it. Okay, so just like this, right, this is every single possible configurations of 1 and 0, ones and zeros with the A and B inputs. Okay, so then you just continue drawing your lines, make it neat, all right. And then it will be time to describe our output. So let's say I just have like a random output lah. I'm not even thinking. Okay, I'm just writing this. Okay, so this is a truth table lah. So how do you read this? How do you read it? You go at it horizontally. So you look at this row, okay, horizontally. Let's say we're looking at this, and then to read it, we say, okay, when A is 0 and when B is 0, then X will be 0. So when these inputs are both 0, because both are 0 in this case, then the output will be 0. Okay, let's look at another one. Let's look at this one. Okay, when A is 1 and when B is 0, X will be 0. Okay, and then last one. When A is 1 and B is 1, X is also 1. Okay, so this is how you read the truth table. And fun fact, right? This truth table actually describes an AND gate. Okay, it describes an AND gate. Yeah, that is not an AND gate. My bad. There we go. It describes an AND gate. So let's move on. For this next part, right? You're actually going to need to know how to what the OR logic gate is, because we are going to be describing the OR logic gate together. So the OR logic gate. Oh, and before I continue, if you would like to pause the video to try and create a truth table for the OR logic gate yourself, you can. The inputs are A and B, and the output is X. So let me, and you can pause now. So yeah, let me just write this above. All right, so let's start filling up this truth table. We already know that the first step is to put down every single configuration of ones and zeros for the two inputs A and B. So let's do that. So 0, 0, 0, 1, 1, 0, 1, 1. And that's all possible configurations. Then we need to write out uh, the behavior, or how the output will be for like this case, or for this case, or for this case. So for the OR logic gate, right, the output is only 1 when either A or B is 1. So as long as one of these inputs is 1, the output will be 1. So therefore, right, it's only 0 when both are 0, and then the rest are 1. Yeah, that's pretty much it. Truth tables don't have to, so far I've only shown you truth tables with 2 inputs, 1 output, but really it can be much more than that. You can have like 15 quintillion inputs and 15 trillion outputs, and that'll be fine. You can have 3 inputs, 2 outputs, that's also okay. Like I can show you an example actually, and this is going to become a practice, and this is the last thing we're going to be doing. I'm going to create a logic circuit right now, and then we're going to describe the behavior of this logic circuit with a truth table. So I'm just going to go ahead and do that now. So this is going to be a bit or quite complicated. So I would suggest that you have a steady understanding of logic gates, like you know them back of your hand, to follow along with this one. Okay, so let's say we have this logic circuit right here, right? There's a NAND gate, and 2 OR gates, and then we have 3 inputs, okay, A, B, C, and 2 outputs, X, Y. So for those who feel they have an adept sensing of logic gates, right, and you think you're quite familiar with the truth table, you can pause the video now to go ahead and try to create a truth table to describe the behavior of this logic circuit here. Alright, so I'm gonna go ahead and do this. So first, I'm gonna draw this line, and then I'm gonna write my inputs A, B, C, and then X, Y. Alright, then I'm gonna draw these lines down. Okay, now right, for my inputs A, B, and C, I'm going to write down every single possible configuration of ones and zeros for these 3 inputs. So yeah. Alright, okay. Oh, what? What? Okay. Anyway, yep. So this is every single possible configuration of the inputs. So now you trying to tell me something? What? What? Okay. Anyway, so now let's describe the the outputs. So we have 2 outputs. So it may be a little bit harder, but we'll see. Okay, so we're gonna go through every single case to do this. So let's try this out. Okay, 0, 0, 0. Um, when 0, 0 for the NAND gate. Oh, you know what? I should probably write down the truth table for the NAND gate and OR gate. So for the OR gate, we actually have it up here. So let me bring this down. Yep. And then for the NAND gate, right? Quick revision. The NAND gate is just the output of the AND gate, but inverse. So it wouldn't be 0, 0, 0, 1. It will be the inverse of 0, which is 1. 1, 1, inverse of 0 if of 1 is 0. Okay, so that's NAND gate, this is OR gate, and now we have the tools to efficiently do this. Alright. So let's say 0, 0, 0. Then for the NAND gate, 0, 0 will be equals to 0. Oh, will be equals to 1. So we do this. And then the output of X is immediately 1 already. Because as long as either leg is 1, then yeah. So this is 1. Then for Y, we'll be taking 0 and 0. So Y would actually be 0. Yeah. And then we can move on. So AB is the same in this case because it's 0, 0. So it will still be 1. And now C is 1 actually. So in this case, Y would be 1 as well. Alright, next. 0, 1. So in 0, 1, the output is still 1. So X is still 1. And then since oh, A and C, the OR gate, so the output is actually 0 here. Okay, 0, 1, 1, 0, 1, 1. The output of the NAND gate is still 1. And then C is 1, so the output will actually be 1 for the Y. Okay, 1, 0, 0. So A is 1, B is 0. So the NAND gate is still going to be 1. And the OR gate will be 1 as well. The output of the OR gate, which is Y. Then here everything stays the same. 1, 1. Okay, so now both A and B are 1. So the output is actually going to be 0 for X. Um for the NAND gate, okay? So this is actually going to be 0. And C is 0, so X is going to be 0. And then for Y, we are at 1, 1. Okay. So since A is 1, right? Y is going to be 1. And now we have 1, 1, 1. 1, 1, 1. So this is still going to be 0, but C is 1. So X will be 1 and Y will be 1. Alright. That was very, very complicated, and I probably made a mistake. So if you think I made a mistake, just tell me in the comments, and I'll definitely look into that for sure. Yeah. Okay, so this is the truth table, and like 50 trillion different like explanations and practices. What am I saying, bro? Yeah. So if let's say in the examination there is a digital electronics question and you're unsure of like how a certain logic circuit works, you can actually do a side working. You can draw a truth table and then you can go ahead and inscribe the behavior of the logic circuit, which may actually help you understand it better. So in times of doubt, right, just try and adopt the truth table into your work, and you may be surprised it might help you. But on a more practical note, okay, wait, that was practical. But in a more note, there will be questions that ask you to draw a truth table based off a prompt. Um, oh, and I guess I should do that now. Okay, I didn't think about that, but there can actually be a question in an examination, like let's say you are designing a toilet bowl. Yeah, okay. When it has two inputs, um, A and B, A and B. When when someone sits down, A A is 1. If not A is 0, them. When poo is dropped, b is 1, if not, b is 0. Design a circuit that, okay, draw a truth table that, oh wait, when someone sits down and drops a poo, the output x is 1, which means flush. Okay, I worded this very, very badly, but basically, this is a possible question. Okay, a more mature version of this question is possible, and then one part of the question will be like, oh, draw a truth table, and then the next part will probably be design the circuit with logic gates, but that's not what this lesson is about. This lesson is about truth tables, so I will be drawing the truth table for this. So the truth table would have two inputs, a and b, and then one output x. Pardon the poor wording of the question. So a, b, and x. And then a, b, right, are the inputs. So we just draw every single possible configuration of ones and zeros. Okay, and then we need to read the thing already to get the output x. So when someone sits down, it's a, if not, it's 0. When poo is dropped, it's b is 1, if not, b is 0. And then the only time output x is 1 is when someone sits down and craps. Okay, so that means a and b must both be 1 at the same time for x to be 1, and no other case, therefore the rest are 0. So this is a very basic question lah, and that's why I can easily just write down the truth table for this. But there may be, in fact, there will be harder questions that you will face in the O level. So this is just a taste, I guess, and I guess it's a good taste because this video is pretty long. So yeah, okay, and I think that's everything you need to know about truth tables. So yeah, thank you for watching.